Welcome to OpenBowShock2d again, and here is the quick video about new features that I have just updated. So let's take a look what we have today. Well, as for the first part of our input geometry, I pretty much didn't input anything new, so there is nothing else to talk about, and I prescribed the geometry for you already to see how our new features are going to look like. So let's go ahead and let's clear all this stuff. But let me first talk about this new feature, which I talked about in the second video, but still didn't specify what it is. It's a slightly new way to set up your geometry. It will be clear. For example, from the previous set of videos, we had this coefficient to be 1, and we clicked the bottom number of regions, and usually we got something like this. We had a table with our lengths and our number of points and also some extra things. Now you can put many regions, and what does it mean is that you can specify the type of grid for each subsection. How does it work? For example, I have my geometry, and you can see that here I have two fairly evident regions to see. First one is a part of the circular cylinder, and the second part is kind of a curve. I use log for it. So I want not to make a C-grid for the whole domain, I want to make it piecewise. So how does it work? I input 2, because I have region 1, which is going to include only my cylinder, and region 2, which is going to include everything else on top and the bottom. And then I put intervals of my location along the characteristic length. For example, it's going to be 1 and 2. And as you can see, x1 is the initial point, and for first part of the grid, initial point is the leading edge, and for the second part is just the edge of my circular cylinder geometry. Let's take a look at our number of points. For each point, it's going to be the unique number. Say I want to put 50 and 50 for my part of the circular cylinder, which is going to be the C grid. And as you can see, automatically this the number of points across the domain is going to be the same because it's algebraic. Because it's a finite difference scheme. And as for the second one, let's put maybe 30. Now, I have also one more feature which deals with the grid generation. It's also the grid height, but now I can put different heights for top and bottom type of parts of surfaces. For example, if I have angle of attack flow at the angle of attack, so to fit my shockwave, if I'm doing supersonic flow, I can make my grid more efficient because I don't need as much space on one half of my geometry. So let's see, for example, I have 5 and 5 and 1, and I put algebraic grid. And let's put lateral clustering term again as 1.1. So you can see the new grid is composed from two grids. One grid which is classical C grid we had, and another one is more or less rectangular grid along these regions. However, the way this grid is generated is not very nice. You have a huge gap in here, and it may significantly affect solution, and in fact it does affect it. Usually this kind of grid doesn't give you a good answer, it doesn't even converge. So we have to do something about it. What to do? Well, the simplest way is to input the elliptic grid, which is going to fix all our troubles and solve our problems. So let's do that. While it's working, I'm going to show you the answers I obtained already for the same type of grid with the same spacing. So here you can see my Mach number curve, yeah, and you can see it looks pretty nice. You see deceleration of the speed at the leading edge, slight deceleration at the extra shockwave region. Same thing on the bottom, but less because your curvature is not that big, the angle change. So we can also have pressure distribution, which also looks nice, and CP curve, which literally tells you that top part has a higher pressure raise versus the bottom one, which is physical. And the last one is the temperature as well as density. So which also gives you pretty reasonable results, and to me it looks fairly nice. Okay, so let's see how much time we have for our grid. And as long as this grid is kind of dense, it's 80 by 50, plus it's MATLAB, and so far I didn't change anything about my efficiency yet, which is probably a new thing. So okay, let's see how much time we have. Oh, it's done. Okay. So yeah, as you can see now, the grid is a lot more uniform, and I tested my code on this grid, which gave fairly successful results. No big drops and gaps, except maybe for this top part, but who cares? It's a free stream. So there are also several features that I input. Let me talk about them real quick as well. This is the simplest one. It's just a new project. You can just click new geometry, and it sends you back to your geometry definition, which literally looks like clear all at some point, but you can get this button at any part of your solution. Load grid, for example, if you save your grid, and you can do that, you can pretty much load it at any time, which is good. For example, you had a difficult geometry and you decided to save it for a set of computations, say for different Mach numbers, so you can load it at any time and test it. Save grid is exactly the thing which you need to do before you load it, which makes sense. Actually, I guess I should switch this order. So you can save the grid at beginning from step 2 when you define the geometry. Sorry, define the grid. You can save it, and if you save it, it gives you a simple window. So let's try that. Yeah, here's this saving window. You can input your name, you can input the folder, so you can do that real quick. Loading works in the same fashion. And another feature is the warm start. The warm start works as follows. If, for example, I had a solution running and I decide to stop it. So if I stop it, then the OpenBowShock2d automatically saves it at the point when I finished my solution. And then if I want to try to solve this problem again, and I don't want to repeat everything from the beginning, I can warm start, which literally opens the project window, where I can open the solution, and it automatically goes on. So that's all. That's pretty much everything about new features of OpenBowShock2d. Check it out. Let me know if they're working well and if you like them, and have a convergent solution. See you then.